Hi, everyone. Can you all see the whiteboard?
We can see the whiteboard.
Okay, good. What answers did you get for the first one? Okay, good. One is correct. Let's see. Dhanush, can you explain?
My sister did the
Okay.
problem.
Okay, Sanvi, can you explain?
She's not here.
Okay. Nidhi or Neil, can one of you explain?
Okay, I just did 4 plus 3, which is 7, and then 7 minus 6, which is 1.
Okay, good. Yeah, so in this case, you have a bag of marbles, and you know that placing 6 in each bag has 4 left over. So the minimum that could possibly be is 4. For Paul, he has 3 marbles left over, so the minimum possible that could be is 3. So if you had 4 plus 3 equal to 7 marbles, when you put it in groups of 6, there'll be 1 left over. Okay, so this will also apply if you had any. So for instance, instead of 4, you could have 10 or 16 or so on, because you know it's essentially all of the marbles become groups of 6 except 4 are left over. And for Paul's the same. All of them become groups of 6 except for 3 left over. So together the leftovers are 7 after the groups of 6. So there would be, from the 7, there would be 1 more group of 6, leaving 1 marble left. Any questions on this? Okay, let's go to the second one. Okay, Ishan, can you explain?
Yeah. So basically, I just did like 3 different equations. I did x plus y equals 26, w plus c equals 15, and u plus v equals 16. And then I know that for even numbers, it could be odd plus odd, or even plus even. So then they're trying to see the least amount of odd integers. So I just did like 6 plus 10. And for 15, it can be odd plus even. So that's 1. And then for 26, I just did 12 and 14. So there's only 1 odd integer.
Good. So yeah, the key kind of trick here is to look at, so you know the first 2 integers sum to 26. When 2 more are added to the first 2 integers, it's 41. So you know the added, the 2 numbers that were added sum to 15. And when 2 more integers are added, the sum went to 57. So that increased by 16 more between 41 and 57. So now if I have an even sum of 2 numbers, the 2 numbers can be even, right? But to have the minimum number of odd integers, I could just set both of them that sum to 26 to be even. As Ishan said, it could be like 20 and 6. Again, 2 numbers that add up to 16, that could be 12 and 4. But when I have to have 2 numbers that sum to an odd number, z plus a equals 15 here, one of them has to be odd, right? In this case, for instance, it could be 8 plus 7 or something like that. One of them has to be odd, and the other would have to be even. So the minimum number of odd integers would be 1. So looking at the other side, what's the maximum number of odd integers here?
5.
Good, why 5?
Because 16 can be like 7 plus 9. And 26 can be like 13 plus Oh, no, 11 plus 15.
Good. Yeah. So these ones that are even, it could be summed as 2 evens summed to an even number, or 2 odds also summed to an even number. So 26 could have been made by 2 odds. 16 could be from 2 odds. So that's 4 odds, plus 15 needs to be 1 odd and 1 even. So that could be a maximum of 5 odd numbers and a minimum of 1 odd number. Any questions on this? Okay, let's move to the last one. Any answers for this one? Okay. It's a little bit more than 12, but Nidhi or Neil, why don't you start off and explain how you got 12?
Well, I kind of did like a web where A, B, and J were the people, and the 4 songs were W, X, Y, Z. And you could see that every time 2 people were connected, it would basically go 12 times in the web. I don't know if that makes sense, but yeah, that's what I did.
So what's an example of?
So A and B could go to W, A and B could go to X, A and B could go to Y, A and B could go to Z, etc. And so once I did that, then I knew 4 times 3 because there's 3 different pairs that it could do.
I see. Okay. So this is the number of ways to say that. So, 2 people want to like the same song, right? So that's saying A and B could have both liked song W, A and J could both like song X, and so on, right? So I think that is part of the question, but let's go back and check. So we know that they do listen to 4 songs. We know that no song is liked by all 3. And each of the 3 pairs, for each of the 3 pairs of girls, there's at least 1 song liked by those 2 girls, but disliked by the 3rd. Okay, so what this means is, so let's try to find one possible way this works. So let's just make sure to make this clear that A, B, and J are the people. So these are the people, and these are the songs. So what is a way that we could kind of satisfy all this? So one way is A and B. So A likes song W. B likes W. And J doesn't like W, right? So that solves it for one of them. How else do we need to kind of assign songs to people to make this work? What else could we assign?
Sorry, can you repeat the question?
Yeah, sure. So we want to just, let's try to first start off in this by just finding one example that satisfies this. So let's try to assign songs to the people who like those songs and see if it satisfies all the criteria. So first I started off by saying both A likes W and B likes W. Now that kind of satisfies the first pair, that A and B both like a song that J doesn't like. Now what about kind of how else could we assign the remaining songs to people to satisfy more of the conditions?
J could like X and B could like X, but then A wouldn't like X.
Okay, that works. What else? Anything else?
And B could like Y and A could like Y, and J could not like it.
Okay, good.
And then A could like Z and J could like Z.
Good. Actually, let's set that for Y itself, because W already satisfies the original one, right? A and B both like W, but J doesn't. So now B and J both like X, but A doesn't. And now A and J like Y, but B doesn't, right? Okay. So
Yeah.
right now we have, so A likes songs W and Y. B likes songs W and X. J likes songs X and Y. Does this satisfy all the conditions?
Yes.
Okay, good. Yes, it does. Let's double check. So they listen to 4 different songs, and no song is liked by all 3. That is satisfied here. Each of the 3 pairs of girls, so one is AB, one is AJ, one is BJ, there's at least one song liked by those 2 girls but disliked by the third. So AB liked W, which was disliked by J. AJ liked Y, which was disliked by B. BJ liked X, which was disliked by A. So that is satisfied. And in how many different ways is this possible? So we found one way. So now in this way, W, X, and Y are all liked by by 2 of the 3 people. What about song Z?
Z could go with A and wait.
So right now, this satisfies all the rules, right? But no one likes Z. We could also make one of them like Z if we wanted to, right?
Yeah,
So where could we put Z if we wanted to?
anyone, A, B, or J.
Okay, good. Could we put it with all of them?
No, because you can only put it 2 out of 3 girls.
Good. Yes. So we could put it with none of them. That's what we already have. We could put it with one of the 3 of them. We could put it with 2 of the 3 of them. But we can't put it with all of them. Okay, does that make sense? Okay, so now we've gone through an example. Now we want to count the number of ways that this is possible. So let's think about, so basically we need one song liked by A and B only, one song liked by A and J only, and one song liked by B and J only. Now the 4th song could be either, so for now, let's not focus on the 2 case. So the last song can either be liked by none of them, or only A, only B, or only J. This covers most of the cases, except if the last song was also liked by 2 of the 3 people. So we'll kind of consider that case separately. So let's count the number of ways that satisfy this kind of formation, which is similar to what we had existing. So one of the songs we said was liked by A and B only. In this case, that was song W. Then we said one of the songs was liked by A and J only. That was Y here. One of the songs was liked by B and J only, which was X here. And the last song, we can say it's either none of them, which is what we had initially, or only A, only B, or only J. Now we're missing this last case where the last song could also be liked by A and B, but that starts getting mixed up with the first song liked by A and B also. So let's forget about those cases for now, and let's just think about the ones that satisfy this. Okay, so now how many ways are there to choose a song that's liked by A and B only?
1.
So let's start off. So right now in this one, I picked W, right? But I could have made X liked by A and B. I could have made it Y, or I could have made it Z, right? So how many ways are there to choose a song that's liked by A and B?
Can you repeat the question, please?
Sure. So let's say so I know that I want to have one song that's liked by A and B. I know I want one song liked by A and J, one song liked by B and J, and this last song can be any of these cases, right? So I have 4 songs to start off with, right? So how many choices do I have to pick the song that A and B like? It could be any of the songs, right?
Yeah, 4.
Okay, 4 choices. Okay, so so once I pick, that could be song W, it could be song X, it could be Y, it could be Z. Okay, now I want to choose a song liked by A and J. How many choices are there?
4.
But so it should be 4.
Oh, 3 because already one of them has been taken out for A and B.
Okay, now what about B and J?
2.
2, good. And what about the last song?
1.
1. Okay, so we have that part. Now the last song, we said there's a few options, right? It could be liked by none of them. It could be liked by A only. It could be liked by B only, or it could be liked by J only. What do I have to multiply by?
Can you repeat the question?
Sure.
4.
Now, yeah. So yeah, someone said 4. Yeah. So now I have these songs selected, right? I know which one of the songs is liked by A and B. One of the songs is liked by A and J. One of the songs is liked by B and J. Now this last song, I could say it's liked by none of them. It's liked by only A, only B, or only J. So this is, in this case, we had W, X, and Y placed, right? So there's 4 ways of saying what to do with Z. Either I don't put Z at all. I could put Z here. I could put Z here. Or I could put Z here. Does that make sense?
Yeah.
Okay. Now, so what is this product?
What?
96.
I
Okay. Now, what are we missing here? Are we counting all the possible cases, or is anything missing here?
No, one of them is missing.
What is
Z. Z. The Isn't it the case that Z is liked by 2 people? Isn't that's what missing?
good? Yes. So I forgot about this case where what if the last song was liked by 2 of the 3 people, right? Okay, so what would that look like instead? So instead of saying, it would be very similar to the first part, right? Where I said one song liked by A and B only. Instead, it would be 2 songs liked by A and B only, 1 song liked by A and J only, or 1 song liked by B and J only. So that's one possibility. What are the other possibilities?
2 songs liked by A and J only, and 1 song liked by AB, 1 song liked by BJ. But then another possibility is 1 song liked by AB, 1 song liked by AJ, and 2 songs liked by BJ.
Good. Okay, let's take that and let's put those in. Okay, so one of them is 2 liked by A and B, 1 by A and J, 1 by B and J. So one is 1 by AB, 2 with AJ, 1 with BJ, and the same thing one more time with 2. Okay, so now how many ways are there for each of these? And let's just pick one of them to start off with. What if I know that I want 2 songs to be liked by A and B, 1 to be liked by A and J, and 1 to be liked by B and J? This case, how many ways are there to kind of assign the songs to people in this case?
There's 3 ways.
Why 3?
Because so 2 songs are liked by AB, 1 song by AJ, and 1 song by BJ. So that makes
So let's start by picking the song that B and J like. How many ways are there to pick that one?
3.
So we have 4 songs, right? Any of the 4 songs could be this one, right?
Yeah.
Okay, so I have 4 choices for this one. Now, once I choose that, how many choices do I have for this song that A and
3.
J like? Anyone?
You have 3 songs.
Okay, so what's the total then?
Seven.
Close. So we have 4 and 3. Should we add or multiply here?
Oh, 12.
Good.
You multiply them.
Okay, so I can choose 4 songs, one of which is liked by B and J, 3 remaining songs for one of which is liked by A and J. Now I'll be left with 2, and those must be the 2 liked by A and B. So I don't really have any more choices left there, but I can choose 4 choices for the ones B and J liked, 3 choices for the ones A and J liked. Okay, what about this case?
It'll be the same.
Same, good. So the same idea, right? I can start off with 4 songs for what A and B liked, 3 songs for the choices of what B and J liked, that's 12, and the remaining 2 had to be liked by A and J. So there's 12 ways for this one. What about this one?
Same, 12.
12, good. So what is the final answer?
36.
Okay, good. Yeah, this is a total of 36. Now, is that the final answer, or do we have one more step?
You have to
one.
add 96 and 36.
And what would our answer be?
132.
Does this make sense?
Yes, it makes sense.
Okay. Now, I think the tricky piece here is kind of once you have to separate these 2 cases, thinking about one song liked by each of the pairs, and the last song liked by not a pair, but only the single or none of them, versus the last song being liked by a pair as well. So I think one thing that might be confusing is could we have just kind of grouped it in here and counted, okay, the last song could be liked by none or only A or only B or only J or A, B, A, J, B, J. Would that have worked in this case? Could we have done that instead?
I think you could have.
It seems like you could, but in that, if you try that out, you'll actually see you'll multiply this by let's see 7 instead of 4, and you actually won't get the same answer. And the reason for this is actually because you'll start double counting. So you picked one song liked by A, B here, and then your last song, it could also be liked by A, B. And then if you picked the first song as A, B and the last song also as A, B, you're kind of counting that same case twice. If you pick the first song as W and the last song as Z, as opposed to the first song as Z and the last song as W. So if you did that, you might overcount some cases because you're trying to kind of count the A-B song different from the last song. In this case, they're always going to be different, right? All the 4 songs will be liked by different subgroups of people. In this case, once you start kind of overlapping, you have to think about those counts separately. And that's what kind of separates these 2 different cases. But once you separate that, you can count this case separately, these separately, and add them up and get the total number of ways. Any questions?
No.
Okay, that's it for today's class. We'll see you next week.
Bye. Thank you.
Thank you. Bye.
Thank you.